Next topic we have Einstein theory of photoelectric effect. In 1905, Einstein explained photoelectric effect on the basis of Planck quantum theory, in which Einstein says radiation travel in the form of discrete photon and the energy of photon is represented by h nu, and photoelectric emission is the result of interaction of two particles. How two particle? One is photon which is coming from this h nu radiation, and another is the electron which is bound to the metal surface, to the photosensitive metal. So the energy, this energy h nu of the incident photon is used up into two parts. First part, a part of the energy of the photon is used in liberating the electron from the metal surface, which is equal to the work function, the energy which is required to liberate the electron from the metal surface by the h nu, which is act as a photon. This energy is used to liberate the electron from the metal surface, and which is equal to the work function of the metal w naught. And second, the remaining energy is used to imparting the kinetic energy. It will give you the kinetic energy for which the liberating electron will come out from the metal surface and it will move, accelerate toward the space. So the h nu is the photon which is equal to the work function which liberate the electron from the metal surface, and the remaining part is to remove out the electron from the metal surface, that is your kinetic energy half mv square. So we can say energy of incident radiation is equal to maximum kinetic energy plus work function. Energy E is equal to h nu, maximum kinetic energy is equal to half mv square max, and work function is represented by w naught. So if this k max, kinetic energy, is equal to half mv square is equal to h nu, when we take it this side, then it will become minus w naught, plus is converted into minus. So k max is equal to half mv square max is equal to h nu minus h nu naught. Work function is equal to h nu naught. H is Planck constant, nu naught is your threshold frequency. This is the formula of work function, h nu naught. And when we take the h as common, then it will remain nu minus nu naught. So this is the photo Einstein equation. K max is equal to half mv max square is equal to h into nu minus nu naught. Next we have determination of Planck constant and the work function. Here we are, according to Einstein equation, when the maximum kinetic energy of electron is given by h nu minus w naught, as we have studied here. This is the Einstein equation. K max is equal to h nu minus w naught, and we know maximum kinetic energy is your stopping potential. Stopping potential represent what? The maximum kinetic energy. So K max is equal to ev naught. So replace K max with ev naught is equal to h nu minus w naught. So when we take the e from this side, it will become divide here from multiplication, then h by e into nu minus w naught by e. This is the equation of straight line. This is, we are having the straight line graph here, as we have studied earlier for metal A and metal B. So we are having only one metal here, that is metal A. When we are plotting the slope, how we can determine the slope? Take 2 points on the straight line and make a triangle having angle theta. This is the triangle ABC, and we know slope is given by the tangent theta. M is represent here slope. And what is the straight line equation? Y is equal to mx plus c. M is your slope, y represent the y-axis, that is stopping potential. On x-axis we are having the frequency, and c is your constant. So slope is equal to, as we know, tangent theta. Tan theta is equal to perpendicular upon base AC upon BC. AC is your Planck constant, BC is your E. So h by E is the slope of the graph. So from here we can say h, E here comes into the multiply E into AC by BC. AC by BC is your slope of the V naught and nu, graph frequency and stopping potential. This is the slope h by E. So here we can measure the Planck constant. And how can we measure the work function? Work function can be represented by the work function can be measured by the intercept. How intercept of this graph? How can we explain the intercept of this graph? Intercept can be given by this graph, that is here in negative minus w by e. So work function is equal to intercept into E. So this is the determination of the Planck constant H and the work function W. This line here represent intercept on the vertical axis minus W naught by E. So in this way work function can be determined.